Hello, this is Mrs. Brown, and today we're going to be looking at factor by grouping. This is a continuation of factoring out the GCF, but this is like a special case where you can't just do it for the whole polynomial, but you can do it in groups, okay? And that's why it's factoring by grouping. So the following has to be true in order to be able to factor by grouping. You have to have at least 4 terms listed, and the terms have to have a common factor that can be grouped. And there are 2 common factors that are the same or additive inverses of each other. And we'll talk about what that means in a minute after we kind of talk about factoring by grouping. So don't panic if you're like, additive inverse, well, what's that? What? Huh? Okay. Don't worry, we'll explain that. Okay. And so this is what the math looks like, but I think the easiest way to kind of go through it is actually look at some examples, because it's going to make a way more sense than you're looking at all these letters going, what just happened? But you can go ahead and pause and write this down, and I'm going to go ahead and dive into some examples. Okay. So let's take a look at factor by grouping. All right, so let's say I have this problem, 8mn plus 16m plus 3n plus 6, okay? Now, there's not something that all of these have in common. Like if I'm looking here, 8, you can divide by 2, but you can't divide 3 by 2. You've got m and n, and this has an m, and this has an n, and this has no variable. So there's not a common factor for all of these things. So I can't just take out the GCF, but I can do it by grouping. And the way I'm going to do that is I'm basically going to treat it like 2 problems and to start with, and group things together that are going to work. So for instance, 8mn plus 16m have common factors that I can remove. Okay, so I'm going to start there. 8 and 16 are both divisible by 8. So I am going to take that out as part of my GCF, because again, I'm finding the greatest common factor. M and M can be taken out. N can't because there's no N here. So this is my greatest common factor for just these 2 terms, and that's what I'm going to do. So like I did in the previous video, I'm going to divide out by the GCF. 8 divided by 8 is 1. M divided by M is 1, so I'm left with N. Plus 16 divided by 8 is 2, and m divided by m is 1, so that goes away. Okay. Now I'm going to do the exact same thing in the other one. I'm going to pull out the GCF. Well, between these 2, I can pull out a 3. There's an n here, but no n here, so I can't pull out anything else, so I'm just going to divide by 3. 3 divided by 3 is 1, and so I'm just left with n. And 6 divided by 3 is 2. Okay. Now, from here, notice I've got an n plus 2 and an n plus 2. Okay. That's my GCF, my greatest common factor. I pulled n plus 2 out. What am I left with? I have 8m plus 3. And that's factoring by grouping. I've taken this long, strange thing and turned it into 2 binomials, which is what we were trying to do. Okay, so again, I grouped it into 2 pieces. I found the GCF of this one and pulled that out, found the GCF of that one and pulled that out, and then I ended up with a common binomial, so it's the same binomial in both, which meant I could pull that out, and what's left over goes in the other parentheses. Okay, so let's take a look at another example. So if I take 6xy plus 15x plus 8y plus 20. Again, when you're looking at this, there are no common factors that can go in all of them. 2's not going to work because that one's not even. 3's not going to work because it doesn't go into those 2. So as you look at the list, there's no numbers that work for everything. I don't have the same variable in all 4 terms, so I can't use that either. So again, I'm going to do it by grouping. I'm going to group these 2 together, and I'm going to group these 2 together, and I'm going to factor them separately. And once I've done that, I should get a common binomial that's in both of them, and that becomes my GCF that I can then factor out. Okay, so it's kind of like factoring in 2 stages. So we're in stage 1 right now. Between 6 and 15, 3 is the GCF between those two for the numbers. This has an X and this has an X, so I can take out X. There's no Y here, so I can't take out Y. Then I'm going to divide by my GCF that I just found for those two terms. 6 divided by 3 is 2, and X divided by X is 1, so it goes away, and I just have Y still. 15 divided by 3 is 5, and X divided by X is 1, so it goes away. Now I'm going to take my second group. Okay, between 8 and 20, the GCF is going to be 4. That's the largest number that would divide into both of those evenly. This has a Y and this has no variable, so I can't take out any variable. So just 4 is my GCF. So I'm going to divide both of these by 4. 8 divided by 4 is 2, and I still have a Y, plus 20 divided by 4 is 5. Okay, now if you take a look, since I factored those two groups, I now have this common binomial for both of them, 2y plus 5 and 2y plus 5, so I can pull that out as my new GCF. And basically, what goes in the other parentheses is what's left, 3x plus 4, because this has to be multiplied by this, and this has to be multiplied by this. So what I did is I just removed that, and I'm left with 3x plus 4, and so that's in my parentheses, okay? So again, when you're doing grouping, you're grouping it into 2 sections, finding the GCF, removing it, finding the GCF, removing it. And if everything goes right, you should have 2 common binomials that you can actually pull that one out, and then you have it factored into 2 binomials. Okay, let's take a look at another example. Now, I talked about this additive inverse thing. Okay, so what that means is that it would be the opposite of, and so we're looking at dealing with a negative. Okay, so when you look here, this is the way that, your textbook's going to explain it, and then I'm going to explain it my way, okay? That I can pull out this negative and make this a minus 6 instead, and then that works, okay? Sure, that works. Here's the way I would think about it, because this is what makes more sense to me, okay? 6 minus a is the same as negative a plus 6, right? Because this is positive. We treat like this like plus a negative, so I can switch it around, okay? To me, when I'm trying to do these problems, I have more success with this than this. But I'll show you both ways, and you can decide for yourself, okay? So let's say I have 3jk, just kidding, minus 6j plus 10 minus 15k. Okay. One of the things that you may notice, like, wait a minute, that polynomial is not in standard form. So right here, you see this is not in standard form. So you know what the first thing I would do? I would flip those, just because it's a lot easier to deal with that way. Okay? So this would be, I would write it like this. Negative 15k. Actually, I think that's supposed to be 5k. I'm sorry. When I'm looking at my problem, I wrote it down right. Plus 10. Okay? So when you take a look at that, now what I'm going to do is I'm going to factor, just like I did a moment ago. Okay? Except this one's negative. So I'm going to start over here. I'm going to pull out, look, if I look, the GCF is going to be 3. There's a J, and a J. So I'm going to pull out 3J. So that's my GCF. There's not a K here, so I can't move that one. And so 3 divided by 3 is 1. J divided by J is 1. So I'm just left with K minus, and negative 6 divided by 3 is minus 2. And J divided by J is 1. So that's that. Plus. Now, here's where this comes in important. Remember that this has to match the other one. Okay, so if I were to just say pull out 5, what's going to happen is I get minus k plus 2 when I divide by 5. Because 10 divided by 5 would be 2, and that's going to be this and this are not the same, so I can't do my fancy pull that out and have it factored into binomials. However, what the book is telling you is take this and make it the negative and pull it out that way. So instead of having this, you would have negative 1 times 5 times k minus 2. Okay. I find that way confusing. Here's what I would say. Instead of making my GCF 5, I would just make it negative 5. The reason I would make it negative 5 is I know that I need to have a minus sign here. So negative 5 divided by negative 5 is positive 1. 10 divided by negative 5 is minus 2. So it's negative 2. So I could have that as plus negative 2, or I could just think of it as minus 2. Either way, it's going to be the same thing. But now it matches. Okay. So if I start to divide this out, and this one's minus, and this one's not, instead of pulling out a positive number, I'm pulling out a negative number. And that's going to make everything work out. One of the things to look out for is you actually have minus signs. Okay. In the first couple of examples that we did, there weren't minus signs in those. Those were addition problems. So one of your clues here that you might have to do that is that there are minus signs involved. But as I said, for me, I would put it in standard form. That's what I did here. I made it negative 5k plus 10. That helps. And then instead of pulling out a positive number, because I know that it has to come out to subtraction and this was positive, I pull out a negative number. And what that does is switch the sign so that I end up with what I want. Okay. From there, you've got your k minus 2, so you can remove that. And what are you left with? You're left with 3 times j plus negative 5 or minus 5, meaning the same thing. Okay. Let's do one more example of those. Okay. And again, I find it much more helpful to go ahead and put it straight into standard form. I find the way that the book did it, I have more trouble with that method. Again, some people may find it a lot easier, but for me, I don't. Okay. So let's say this is my problem. Okay. It's supposed to be a 4. It looks kind of wonky. All right. Again, I'm noticing this is not in standard form because the constant is not at the end. So the first thing I'm going to do is fix it. Okay. I think I have an extra letter. There's not supposed to be a T there. Okay. Sorry. So negative 8t plus 4. Okay. So now that I'm in standard form, I'm going to start with this first group, and then I'll worry about the second group. When I'm doing this, between 18 and 9, the GCF is going to be 9. Between R and R, it's going to be R. There's a T here, but no T here, so I can't pull that out. So I'm going to divide by my GCF, which is 9R. 18 divided by 9 is 2. R divided by R is 1. So 1 times 2 is 2. And I still have a T. Minus 9R divided by 9R is 1. It's not 0. By the way, this is one of the common mistakes people make when they're factoring out the GCF. There has to be something there so that when you do this times this, you actually get back to the original problem. If I were going back the other way. But this divided by this is 1 whole. It's not 0. So making sure that you have a 1 there. Okay. Now, again, as I'm looking, I see a plus sign here, and I know it has to be a minus sign if I'm going to be able to factor out that binomial. So instead of factoring out a positive number, I'm going to factor out a negative number. And between 8 and 4, 4 is the greatest common factor. So I'm going to factor out negative 4. There's a T here, no T here, so I can't do anything with that. So I'm just going to divide by negative 4. Negative 8 divided by negative 4 is a positive 2 times t. 4 divided by negative 4 is negative 1. And so now I have something that matches. Now that it's something that matches, I can remove that binomial because that's my GCF here. And then I've got 9r left, and then plus negative 4 or minus 4. And that would be factoring by grouping. Okay. This one's a little bit stranger, but again, take it in sequence. Group, do each of these as separate problems, and then you can pull out that binomial at the end, and the second binomial is what's left over. Okay? I hope this helps, and I'll talk to you soon.